Okay, one of the main topics we have in this class is similarity. Okay, so we have two similar figures, and our goal is to actually figure out what is the length for x and for y. So before we do that, I want to make sure we understand what similarity actually tells us about the figures. Well, one thing similarity is true about is that our angles, corresponding angles, will be congruent. So angle Q, which is in the same position on my list as angle S, as S for the letters, I know that Q and S are congruent. U and P have the second spot in my description of my similarity, so U is congruent to P. A will match O, and also angle D is congruent to angle T. So we have all the angles that are corresponding are going to be congruent. Now for the sides, when we look at our sides like QU and SP, they're going to be proportional. So if I take the length of QU divided by SP, it has to equal any other matching sides as long as I keep my orders correct. So it'll match like UA over PO, or AD over OT, or even QD over ST. So in each one of these cases, I started with the left-hand figure and I did it over the right-hand figure using the corresponding sides. So the corresponding sides are proportional. They're going to all have the same ratio. So if I take my measurements, like QU divided by the measurement for SP, which in this case was Y, if I did 10 over Y, it has to match any other kind of combination. So let's take a look about actually using this to be able to solve a problem. So let's say we're going to first start with X. If I'm going to find the length of X, then I need to find what it matches on the other figure. Well, notice how I got the red and the green matched here. It matches the red and the green on the other side. Or I can look at my description of my similarity. QD matches ST. QD over ST. So I'm going to do QD over ST, and then I'm going to have to find something else to be able to match up. Well, I can't use the Y because then I'd have two unknowns. So I'm looking at this 8 is between P and O. So P and O, I've got to match it up with U and A. So X is to 12, QD is to ST, as UA is to PO, or 5 is to 8. Once you have this, we just cross multiply. We have 8x equals 60, and solving at x equals 7.5. Now we're going to solve for y. Okay, so y is between the red and the blue one. Now I'm going to show you can actually start from the right-hand side and do it over the left-hand side. So I look at my red one, my single arc one, and my double arc. That's going to correspond with 10. Or again, SP matches QU. So I'm going to do y over 10. And again, because I want to use the same ratio we did earlier, I'm going to do 8 over 5. So since I started with the right-hand one, I've got to start with the right-hand one when I do my second ratio as well. So y over 10 is equal to 8 over 5. I get 5y equals 80, so y equals 16. So the question is just matching up your like parts. Now the more common ones we're going to run across are similar triangles. So sometimes you won't be given any letters, you'll just have things that are marked. You just got to figure out what matches with what. Okay, so again, I'm going to try to solve for x. So I look at my angles that match. This angle matches the blue angle on the other side, and then we have this one with the dash through it matching on the other side on this side. So x is going to match with 18. So I'm going to go from left to right again. So I'm going to do 18 is to x. Now I got to find the one that matches with the 16. Well, 16 had this single arced angle. It would be matching with the single arced angle down here. So I'm going to do 18 is to x as 24 is to 16. Cross multiplying, I get 288 equals 24x, and then solving I get x equals 12. Now you can actually do a little bit of checking on the problem. So if I look at my figure, opposite the 24, opposite the angle, this angle right here, the red angle, is the largest side. So my largest side needs to be 16. X corresponded with 18. My smallest side was off, past the 14. But let's say if I got an answer where my answer was 20 instead of 16. I knew that wouldn't be possible because I know the largest side has to be opposite the same angle that had the largest side on the other triangle. So that acts as a little bit of a check to see if your answer makes sense. Sometimes you can't tell if you make a mistake, but sometimes you can. If I got an answer that that side was supposed to be 20, I could have possibly realized, oh, I made a mistake. Okay, one of the common ones we're going to have are overlapping triangles. Now we have two similar triangles. We have a triangle that's a small one here, and then the large triangle on the outside. What makes these similar is we do have our angles matching up. We have a corresponding angle here and here. Since we have two parallel lines, the corresponding angles are going to be congruent. And we also have these two are corresponding. We could also even use the angle that's at the very top of the figure. Up here, it's in both triangles, so it's going to match itself. That's a case of reflexive. So to kind of help out, I'm going to redraw these triangles. We have the small triangle here that had the sides of x and the side of 10. Then we have the large triangle. Well, it had the side of 18, but I need to figure out what is this long side right here. Well, you got to realize you got to put these two pieces together. Common mistake that students make is they want to make that just 20. But it's this whole piece right here all put together. So if you're not sure what operation to do to combine the 20 and the x, make a number up for x, like say 5. If x was 5, and I want to find the whole length of this, you know that you would just add 2 together and get 25. Well, once I realize I'm just adding the two quantities, I could just add them together. A lot of students will make the mistake of calling it 20x. Well, if that was 5 and this was 20 and I did 20 times 5, that would make that side 100, which really does not make sense. So sometimes making up numbers does help. So this side is actually 20 plus x. And I'm going to put it over here. So if redrawing the triangles helps, you may want to do that. But you have to be aware that what you're working with. And a lot of students can actually do this part without having to redraw it, and that's fine as well. Okay, so now we're going to match up our triangles. So I'll do 20 plus x over x is equal to 18 over 10. It's a little bit easier to match them because they're not churning them or twisting them. They have the same orientation. Now we can solve it. Just cross multiply. We have 200 plus 10x equals 18x. So 200 equals 8x. And then x would equal 25. Now notice on this particular figure, it is not necessarily drawn to scale. So it looks like x is smaller than 20 when in fact, after I solved it, I got the answer that x was bigger than that value. It just means that where I drew my lines are not exactly the same. Not in the correct position from the triangle, but they're not necessarily drawn to scale, so you have to be aware of that. You can use geometry facts such as largest angle is opposite the largest side, but don't look on it based on what the figure looks like.